Okay, so we just said about, we're talking about data structures. R has a wide variety of data, of objects for holding data, we said. And here are the first three: vector, matrix, and array. And then we have a data frame, which looks just like a matrix, but it's what can be in it is less restricted than what can be in a matrix. A matrix, everything has to be of the same type. So if you have a numbers here, everything has to be numbers. If you have characters or nominal data here, everything has to be nominal data. But a data frame, no, that's not true. You already saw that. The data frames that you've created, you saw that wasn't true. Here, this couldn't be a matrix because you have numbers and you have characters and so on. So it's not, could not be a matrix. And then a list is more general than this. For example, these what should I say? If there are 4 elements here, there have to be 4 elements here, and there have to be 4 elements here. Whereas an array, a list, you could have 4 elements here, 10 elements going down this way, and just 3 elements going down this way. That could be a list. There are several terms that are idiosyncratic to R, and thus confusing to new users. Okay, so idiosyncratic means that R uses in its own special way, terms that R uses in its own special way. So in R, an object is anything that can be assigned to a variable. That's a little different than what's standard language for what we mean by an object in programming. Usually that's not the definition of object, of the word object, when we're talking about programming. But here, an object is anything that can be assigned to a variable. So if you have a variable x, anything that you could assign to that x is called, in R, an object, or could be called an object in R. This includes constants, that's just a single number, data structures, like we just saw. All these are data structures, so any of these could be assigned. We could say x equals some matrix, or x equals some array, or x equals some data frame. You did that already. You named, I think you gave it a data frame a name. But also functions can be assigned to variables, and even graphs can be assigned to variables. So they would all be called objects. It's a little different language than if you've studied other languages, other programming languages. They don't quite use the word object in this way. Objects have a mode, which describes how the object is stored, and a class, which tells generic functions like print how to handle it. So that's a little confusing at this point, but mode basically is basically like a data type. A data frame is a structure in R that holds data and is similar to data sets found in standard statistical packages, SAS, SPSS, and Stata. By the way, just let's quickly take a look at that. What are these other standard statistical packages? Now these are 3 that are mentioned here, and these 3 cost money. But let's just take a look at their websites quickly just to see that they are real. Okay, this is the SAS page. Now my computer connection is really slow and it's not loading fully, but this is the page. You can find it yourself. Anyway, it's very expensive software. Only big companies use it. I think license costs about, just one license for one person costs like $50,000 US, something like that. This is SPSS, which was recently bought by IBM, and this is a software that many academic people use, and I believe we have a number of copies at APU. And this is called Stata, and this is another package that a lot of research people use. and I think there are a number of professors at APU that are using Stata. These are all commercial, whereas the software we are using, R, is free and open source. Okay, so anyway, most of these will usually use something similar to a data frame when they analyze data. The columns again are called variables, and the rows are observations. They may different people will use different words for these, but everybody uses words columns and rows. But some people call these, instead of variables, they'll call them attributes. Other people will call them dimensions. But whatever, doesn't matter what you call them. You can have variables of different type, for example, numeric and character, in the same data frame. Like I said, data frames are the main structures you'll use to store data sets. Factors are nominal or ordinal variables. They're stored and treated specially in R, and we'll learn about that in a little while. Okay, vectors. So we've done all of this, so I'm not going to ask you to retype it now because you've done enough of it already. Vectors are one-dimensional arrays that can hold numeric data, character data, or logical data. Now actually I don't think we stored non-numeric data in our vectors yet, did we? But you can do this. Okay, so you can store character data in a vector, so B contains these three objects. Or you can store what we call logical, and it turns out this is used a lot in analysis. You'll see as we go along. Here A is a numeric vector, B is a character vector, and C is called a logical vector. Note that the data in a vector must only be of one type or mode. Okay, one type or mode. Mode and data type are used kind of in this same way. Numeric, character, or logical. You can't mix modes in the same vector. Note, scalars are one-element vectors. Examples include this. So here we're assigning the value 3 to F, or we're assigning the character string US to G, and here we're assigning that to H. So I guess these are all, they're calling them all scalars. Usually scalars refer to numbers, but maybe he's allowing just one element vectors to be called scalars. It's a little bit unusual language. Scalars usually referred to numbers, but here maybe everybody in R refers to one element vectors as scalars. You can refer to elements of vector using a numeric vector of positions within brackets. Okay, now here is something we haven't done, and this is interesting and fun, and we have to do it a lot. So going back to the vector A up above here, right? So what does A look like? Maybe we should do this. So I'll put this in there. Put it in my R like that, and now suppose that we do this. Now what does this mean? Let me put it there, and then let's think about what it means. Okay, so what does this mean? Well, first of all, here's A. Second of all, these are brackets that we haven't seen before. These are square brackets, so we haven't seen those before. Third of all, we have C in there, and C, we know what C does in general. It's the concatenate or combine operator, and it's creating a vector with two elements. The elements are 2 and 4, right? You know that. So what does that mean to put that in here? Well, actually, I don't want to do that yet. Let's do this. A, because that's a little bit too complicated. Let's just do this, because that's what this is doing. That's what this was doing, right? It was actually this is too complicated. Let's just do this first. So what does that do? So first of all, what is A? A is 1, 2, 5, 3, 6, negative 2, 4. What this means is give me the second element in A. So what is the second element in A? It's a 2. That's not a good example. Let's do this. 3. This says give me the third element in A. What is the third element in A? It's 5, so this should give me 5. Okay, so how about this? A 5. What's that? So that's going to give me the fifth element in A, which is what? 6, right? Okay, now going back to their example. Okay, now let's try this. So C will create a vector with two elements, 2 and 4, and when we do this, we get the second element and the fourth element. Okay? So we create a vector and we use it as we say, okay, here I say this is the index, the third, this is the index number, what do we say, I forget. Anyway, it's the third index for this vector A, and this is the fifth index, and now we have the second and fourth index for A. Okay, so this refers to the second and fourth element of a vector A. Here are some other examples. A3, this one is going to extract the first, third, and fifth, so that's 1, 5, and 6, right? 1, 5, and 6. And this one, this is the 2 through 6, so that's going to be this one, 2, 3, 4, 5, 6. These, right? So that's 2, 5, 3, 6, negative 2. Okay? So we hadn't seen these square brackets before, and now you see what they're doing. They give you they allow you to put in the index in order to extract that element or elements from the vector A, or from any vector, whatever vector you put here. Okay? And here, this is familiar. This is the colon operator, and that we know gives us a sequence of numbers from 2 to 6. The colon operator was used in the last statement to generate a sequence of numbers. For example, this we know is equivalent to that. Right, this gives us 2 through 6, 2, 3, 4, 5, 6. Okay, so that's a bit about about vectors and extracting elements from a vector, like the third element from a vector. Okay, now matrices. A matrix is a two-dimensional array where each element has the same mode. Remember, it has to have the same mode if it's a matrix. So you might say, well, why should I use a matrix when I can just use a data frame, and then I don't have to worry about all the elements having the same mode, because data frames, I don't have to do that. So why should I bother with a matrix? But matrix calculations are faster than data frames, so sometimes you might have to think about that. But anyway, they all have to have the same mode. They can all be numeric, they can all be character, it can all be logical. Matrices are created with the matrix function. The general format is like this. So this is kind of complicated, right? But we're going to make it not complicated. But so of course you know what this means. That means we're assigning something to this variable. Okay, and then we're going to do all of this. And this is going to create a matrix, which is going to be assigned to this. So what is all this? So what first goes in there is a vector. Now that sounds kind of weird. We're going to put a vector in here to create a matrix. Let's see if we can find a simple example of this before we go too far. Okay, let's do this. So here. So we're going to assign all of this to a variable called y. We're using this matrix function to create this matrix. Now they said we have to put in a vector first. Okay, so we have to make a vector. So this is a vector, right? This is the colon operator, which gives us a sequence of numbers from 1 to 20, right? Let's make sure of that. Okay, so here's 1 colon 20, full colon 20, and we get this sequence of numbers. So, okay, so we made sure of that. So this is creating a sequence of numbers from 1 to 20. In other words, it's a vector. And we said that there has to be a vector that comes first. That's what it said here. We need a vector as the first argument. Right? So we're putting a vector as the first argument. So how is this going to create a matrix? Well, we're going to say how many rows and how many columns. N rows is one of the arguments in this matrix function, and we can assign it a value like this. Assign n rows 5, and then n column is another argument in this matrix function, and we can assign that a number. Here we're assigning it 4. Now, of course, here 5 times 4 adds up to 20, and there were 20 elements in here. So that's good. Okay, so now here's one weird part, a kind of annoying part, and I don't know why they did it this way, but this is the way they did it, so we have to get used to it. So what we're going to do is we're going to take this vector and spread it out over the matrix structure. And by the matrix structure, I mean it's going to have 5 rows and 4 columns. Now the only weird thing is the way that we enter these numbers 1 through 20. So do we enter it 1, 2, 3? No, we don't do that. That's so weird, but that's the way they do it. They do it 1, then 2 down, then 3 below that. So they're entering it like this, and then like this, and then like this, and then like this. That's the way it's done. That's the way. Now you can change that behavior, but that's this default behavior. Okay? I forget, what do they call it? Column entry or something. I forget. Maybe they'll mention it. Okay? But that's how it's done. So now we have this matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's a matrix. And how many rows are there? 1, 2, 3, 4, 5. That's what we said. There should be 5 rows. And how many columns are there? 1, 2, 3, 4, 5. Okay? And don't worry about this up here for the moment. And don't worry about these here for the moment. Okay? So, we've created a matrix. So let's go back and look at this again. A matrix is a two-dimensional array where each element has to have the same mode. Matrices are created with the matrix function. The general format is here. The variable name, use the matrix function. First thing you have to put in there is a vector. Then you have an argument called nRow, which you can give a value, which will tell you which will say the number of rows the matrix will have. You also have a variable called nColumn, which will allow you to assign a number of columns. And now there's other stuff here. By row is another variable that we can set, or an argument that we can set. Dim names is some kind of list, which probably gives the names. If you want to have names for along here or names down here, you can use that. For example, suppose this was, I don't know, Mazda, Toyota, Nissan, and Subaru, right? So you could have those names up here, or you could have names down here. So if you wanted that, you could do that by setting these arguments. We'll talk about that later. Okay? Anyway, that's how you could create a matrix. Okay, let's stop here and then continue.